In the lesson today, we are going to be taking a tour of the periodic table. We're going to learn about the different families on the periodic table and some characteristics of those families. Throughout this lesson, I am going to be giving you colors for each of the families. So I have provided you with a blank periodic table in this module. If you want to go ahead and print that off, or try to color it in on your computer as we're going along with this, that will be a very useful tool for you to have in the future. By the end of this lesson, you should be able to use this periodic table as a very important tool. Some terminology you're going to kind of need to know for this class and future science classes are groups and periods. Groups, there are 18 of these, and they are the columns as you're moving across the periodic table. They are the ones that are going up and down. Period, there are 7 of these, and these are the rows that you look at as you're moving down the periodic table, and they are the ones that are going from left to right. So let me show you what I'm kind of talking about here. When I'm talking about groups, I'm talking about these ones, the ones that are moving up and down as you're moving across the periodic table. And if you notice, if you're looking at the top of the periodic table, these have numbers, and you can see that these numbers are moving 1 through 18. And then, when I'm talking about periods, I'm talking about these ones, the ones that are moving across the periodic table. And if you notice, these ones don't have any numbers on the side, but if you wanted to, you could number these 1 through 7 down the table, so it could kind of help you visualize what you're looking at. If you're wondering why these lanthanides and actinides are not placed in the periodic table, they do actually fit in this area right here, but they're not put there because they don't fit the characteristics of the other elements that are in that location, and we will talk more about that later. So, metals. These are located on the left and in the middle of the periodic table. Some of their properties are that they are conductors of heat and electricity, which is why we use them for piping and for our electrical wires. Another one is that they are ductile and malleable. So if you remember from physical and chemical properties, we talked about ductile, and that it means the metal can be drawn into a wire. Again, another great reason as to why we use these in our electrical wires. Malleable, if you didn't already know, means that you can flatten a piece of metal into a sheet. So it won't break as you're flattening it, it'll just kind of keep flattening out. They also have luster, which means that they're shiny, and these are more willing to lose their electrons when they're bonding, so they're forming a positive ion. If you remember from our isotopes and ions lesson, we talked about what these were called, and we call these cations. So to kind of show you what I'm talking about when I'm talking about where the metals are located on the periodic table, it's everything in blue here. So it's going to be all of the blue stuff on this table. So now let's talk about some nonmetals. These are on the right and the top side of the periodic table. Some of their properties are that they prefer to gain electrons when they're bonding. Again, if you remember from our isotopes and ions lesson, these will form then negative ions and become what we call anions. They are non-conductors, or what we would like to call insulators. They are not used when it comes to heating or plumbing or any kind of and then they're also brittle. So if you tried to go and flatten these into a sheet, kind of like you would with the metals, instead of actually flattening, these will break into tiny pieces. So if you've ever tried to toss a rock really hard into the ground and you just watched it shatter into a million pieces, that is what would happen. And then we've got semiconductors, or also what we would call metalloids. The characteristics of these are both between metals and non-metals. This is dependent upon their condition and kind of where they're located. So then we have what we would call our staircase, and that's where these semiconductors or metalloids are located. It is boron, silicon, germanium, and I apologize, I do not know the names of the rest. But if you have your periodic table in front of you, go ahead and get a yellow color, or you can pick a different color if you want, just as long as you kind of keep a legend of what your colors are. And I'll kind of show you where to put these on your periodic table. So when I'm talking about the staircase and kind of how we should color these in and where we're going to color in, we're literally going to be making what looks like a staircase. So if you wanted to draw this in, you could. And on your blank periodic table, you can write the elements if you would like to, or you can write their atomic number or whatever may work for you. I'm going to write these in here just so you get an idea of what I'm coloring for this stair step, since that's kind of an important part of this. So I said the semiconductors or the metalloids were B, Si, G, As, Sb, Te, and Po. So that's what I'm kind of going to make that look like, is I'm going to color that in just like that. Now let's talk about some diatomic molecules. These are bonded to each other. And we did talk about this a little bit when we talked about calculating molar mass and molecular mass, but these are all of the ones that you are typically going to find bonded like that. That's nitrogen, oxygen, fluorine, chlorine, bromine, iodide, and hydrogen. So what we want to do is we want to make a number 7 with these. And we're going to do this on the periodic table, starting with N and moving all the way down to iodine, and then making a little box around hydrogen. And I'm going to show you how to do all of these, so don't panic if you're not understanding what I'm doing or what I'm talking about as I'm saying it when the words are up. So when I mean that we're going to make a 7, we're going to start at nitrogen, and nitrogen is the third box in right here. So we're going to start here, move all the way down to here, and we're going to move to the third box from the bottom, and you are quite literally going to make a 7. You kind of see how that looks like a 7? But do not color these in, because we're going to color some of these different colors. The 7 just indicates that these are diatomic, so they bond to themselves. So the first group we're going to talk about is alkali metals. These have 1 electron in their last energy level, and they form a +1 cation, because when I remember when we talked about metals and I said that metals prefer to give up their electrons rather than take on more. So in this group, all of these form a +1. These are things that react so violently in water that they are stored under oil. They are found in compounds typically. A lot of these are found in different kinds of salts. They are very soft, shiny, and basic when in water. So if you've ever talked about the pH values of something and how 7 is neutral Anything above 7 is basic, and anything below 7 is acidic. So all of these are above 7. And on the periodic table, we're going to color these red or whatever color you choose. So if you're looking at the periodic table, you will notice that hydrogen is in your group 1. We are not going to color that. So you are going to start at lithium and work your way down. And then if you wanted to write a note that said that these form a +1 to kind of help you visualize, you know, hey, these like to give up 1 electron. And when we come to chemical bonding, this is going to help you a lot if you have this little note. So I have a video here that I am going to play to show you kind of what these react like.
Yeah.
Ready?
Yeah.
Very satisfying reaction.
Putting in the grass, look.
So if you've seen what happened there, the gentleman stuck something in just what it was a jug of water, and it exploded instantly. That is what happens with these, and as you're moving down group 1, rubidium reacts pretty crazy, and it takes a little bit, but it creates a huge explosion. And as you get down to cesium and francium, you can't really find videos for those because they are very dangerous when you stick them in water. Now let's talk about alkaline earth metals. These have 2 electrons in their valence shell, and what I'm talking about when I say their valence shell, that means their very last energy level. So when you're drawing a model of them, so if I wanted to look at beryllium has 4 electrons. So this is my first level. This is its valence shell. And as you can see, it has 2 electrons in it. That is what I'm talking about. So these typically form +2 cations because, again, they are a metal. They prefer to give up their electrons. They are less reactive than group 1. Not to say they're not reactive when it comes in contact with other metals, but you can have magnesium metal and not have any kind of issue. On your blank periodic table, we are going to color these blue or whatever color you choose. So it is just going to be this group right here. And don't forget to write a legend that states that whatever color you have is the alkaline earth metal. And again, if you want this little cheater, you can write a +2 up at top to make sure that you kind of know that this creates a +2 cation.